Good morning, everyone. My name is Mike Masterson. I'm one of the automation specialists with the Reynolds Company out of the Houston office. And we welcome you to the first Tech Talk of the year. We're starting off 2021 strong, hopefully. And again, I'd like to invite you to the first one of these, and just let you know, we have many of these already planned and on our calendar. So if you go to reynoldsonline.com, you can go back and take a look at some of these sessions we have upcoming. Today, we're going to be talking about IIoT and just some general ways we approach it. Our panelist today is leading everything will be David Newton, one of my counterparts out of the Houston office, and myself and some of my counterparts will be backing them up, and we'll be taking any messages you might have. Just to let you know, we will be recording this, so if you need to go back and review any of the information here, you certainly can. And with that, David, let's talk about some of the things we do have coming up on our calendar. On January 27th, we're going to be looking at some augmented reality wearable equipment with RealWear. We're going to look at Logix to Micro 800 migration in February. We're going to take a general look at fiber optics and building faceplaces, and the highly integrated heart, which is a new function that was brought out with V33 of Studio 5000. So those are all the tech talks that we have coming up. And just to give you a reminder, a tech talk to us is not as fully in depth as one of our users groups, which generally run a lot longer. Our tech talks are really aimed around specific subjects, and they're really more 20 to 30-minute conversations. Our users group coming up next week, we're going to do an automation update. Basically, we'll be discussing a lot of the product and equipment that was released during Automation Fair in November. And then we're also going to have a network seminar with Panduit coming up, and in March, we're going to be looking at scalable OEE. All registration is on reynoldsonline.com, and please feel free to reach out and sign up for any of the classes there. And with that, I will hand it off to David Newt.
All right, thanks, Mike, and good morning to everyone. I'm going to spend the next few minutes talking about IIoT, or Industrial Internet of Things. And when I prepared for this talk, what we decided to do is we wanted to frame the Industrial Internet of Things from our perspective, from a controls perspective and from Rockwell's perspective, and how do we connect to that world of IIoT, or the Industrial Internet of Things. So in preparing for that, I started out kind of from the beginning, and so I thought, well, and I know some of our customers are very familiar with IIoT, but some not so much. And so at the beginning of this conversation, I'd like to start kind of from the beginning. And so when I prepared, I thought, well, let me go to Wiki and see what Wikipedia defines as the Industrial Internet of Things. And so Wikis says, okay, it's interconnected sensors, instruments, and other devices networked together in industrial applications. And so as I read that, I thought, well, that's what we do already. And that's what we've been doing for 25, 30 years. So how is that really IIoT? I'm not sure. And when I was thinking about that, this diagram kind of came to mind, and a lot of you are familiar with this, but some of you may not be. And so I thought I'd take just a few minutes to talk about it and to go over just at a high level what this diagram and architecture is showing. And so this is really the world we live in as Rockwell providers and of automation and software solutions. And so you look at the bottom, level 0, we have our sensors, so we have our instruments, our devices, etc. And level 0 communicates to level 1, and so level 1 is what we call our control layer. So that's our Logix, that might be our Micro 800s, that's going to be our IO, etc. All that connectivity from level 0 to level 1. And then when we go to level 2, that's going to be a lot of our software. So that's going to be our, and hardware, that's going to be our operator interfaces. That might be our supervisory control system or our SCADA system that we have. And so those first three levels kind of make up a kind of an automation zone, and there's security built around that. And you know, this is a tried and true method of implementing automation that's really we've been doing for a long time. And then the next layer, you have your site operations. So you may have your, you know, your maintenance servers, your asset center, your historian, SE, et cetera. And then, you know, over the years, we've just, companies have decided, well, we need to send this industrial information up to our enterprise to do some analysis or some record keeping, et cetera. So we've devised this zone where we have firewalls on either side, and we go through proxies and gateways and what have you. And then all of a sudden, some of this information that was generated down at the plant level is now available to the enterprise. And so we've been doing this for a long time. You know, we've also, a lot of us have seen this picture before. So, you know, is this really IIoT? And so I would say, no, not really. And so I said, well, I guess I need to dig a little deeper. So I need to really discover what this IIoT thing that everybody's talking about, what this really is. And so this is, again, this is the Purdue Enterprise Reference Architecture model, or, you know, really what we, a lot of our typical solutions follow. Not every solution has every level, but a lot of them do. And so when I look a little bit deeper at this model, you know, we use various communication protocols to go from one level to another. So for example, level 0 to level 1, a lot of times that's going to be your basic electrical power. So that might be milliamps, that might be voltage, depending on what devices you're communicating with. That also could be some field bus communications. And then when we go from our control layer up to the supervisory, well, now we might get into, or we get into remote IO, we might get into producer consumer networks. We get up to the level 2 and level 3. Now we're talking about client server architectures and maybe OPC and so, and then when we go up to the enterprise, we may be looking at completely other different communication models and protocols and things. And so the ultimate story here is in our model that's tried and true, that we support, that we implement today. Well, there is a certain level of configuration that's required to go from one level to the next. And typically, in this model, if you have sensor instrument information that you ultimately want to get to the enterprise network, you are required to go through every level. And there's good reasons for that. But these levels do require, you know, engineering time, configuration. There could be configuration costs, whether that's software costs or implementation costs, et cetera. So the question you may ask, or the question that's been asked, is there an easier way to take this data from level 0, level 1 of our model,
that's correct,
up to the enterprise?
These will be wired.
And so that's the question that IoT has an answer for. And so putting the Purdue model to the side for a moment, let's talk about the IoT architecture, or the Internet of Things architecture. And so in this diagram, I've borrowed from a website called opcrouter.com. Not something I came up with on my own. But this architecture is an example of what's called MQTT, which stands for Messaging, Queuing, Telemetry, Transport. Those of you that are familiar with IIoT or Industrial Internet of Things are probably also familiar with MQTT. So MQTT is a messaging protocol that's used quite a bit in the Internet of Things architecture. And so looking at this diagram, and this is a single instance, say I've got one temperature sensor, and this information I want to get up to the top level, maybe up to the enterprise or up to be able to view. So really what I do is I publish this information or publish this data, and I connect it to what's called an MQTT broker, or in the automation world, we might call that a namespace or a data repository, like a database or a historian. Be this similar aspect here with the MQTT broker. And then this broker takes that data and it makes it available to whoever wants to subscribe to it, albeit with security, etc. So I may have a laptop, I may have a mobile device. Maybe an example might be your some home automation. Maybe I've got a smart thermostat at home, and when I'm at work, I want to know what the temperature is of my house and when I'm at work. This is the type of network you'd use to do that. So you're basically circumventing a lot of the layers that we have in our traditional automation system, and I'm going directly from the sensor all the way directly to that enterprise or that analytic device. And so that, in a nutshell, is what IIoT is a simple, lightweight messaging protocol network. And the other thing to keep in mind here is my sensor is really disconnected from my laptop and my mobile device here. So my publisher of information is brokered through this broker, this namespace, but I don't have really a direct connection between my sensor and my mobile devices. So the question is, okay, so I get that IIoT, well, it looks like maybe a little bit simpler than our traditional model, but why do I need this architecture in the automation space? And so in my research, I listened to various presentations in the past, and I got some good information from one of our Encompass partners called Grace Sensing. They had a talk on in the automation fair last year about this, and so they came up with a couple of reasons in their experience that are the most pertinent to us. First one being this data infrastructure assists already depleted maintenance resources at facilities. And so I know with my experience, I rarely hear, whether it's a refinery or a power plant or et cetera, I rarely hear from my end user telling me, oh, guess what? Our maintenance budgets has been increased, or we're able to hire more maintenance technicians or maintenance support. Usually it's the opposite. And so this data that we're getting from our sensors and et cetera, is going to help those depleted maintenance facilities resources get more information about their equipment. So that's reason number one. And reason number two, ultimately, is to reduce unplanned downtime. And so a lot of this data that we generate from our assets in the larger organizations, that may go up to maybe an enterprise analytics team. And those analytic teams, whether that's internal or external, might be analyzing this data and doing some predictive maintenance or et cetera. And so that ultimately, the idea is that leads to unplanned downtime. So these two concepts are not new to us. So again, the question is, don't I get the same information from our existing model, from our level 0 to level 5? Well, yes, that is true. But typically what we see is the IIoT solutions based on the architecture, the simpler architecture, requires fewer resources and can be quicker to implement. And so that's why we see this type of architecture being really favorable towards the maintenance groups within our users. Because a lot of times they may not have the resources or the capital to implement large data projects that it would take to bring a lot of data all the way up through our traditional information stack. So that's the why. That's a little bit of the why. So our maintenance customers, this could be a very valuable thing to them. So the next question is, now that we've defined IIoT, so how do I connect my existing infrastructure and my Rockwell controllers to this network, and how do I do that? So let's talk about that for a little bit. So there's a couple of technologies that I'd like to talk about today. And the first one is, how do we get controller data via MQTT? And to remember, a couple of slides ago, we introduced MQTT as one of the primary industrial Internet of Things protocols that exists today. A lot of our users use it, a lot of our partners use it, so it's very, very accessible. And the good news is, both with the Logix platform and with the Micro 800, we have two solutions to communicate over MQTT in our controllers. So I want to talk quickly about our first one, which is the Logix 5000. And so Logix 5000, we do have sample code that's available from Rockwell that has existing AOIs or AOIs to communicate to that would exist in the controller that will provide data, publish or subscribe data to and from an MQTT broker, and that is available for no charge and available for free download. Keep in mind that the add-on instructions, or the AOIs, do require in the Logix to use the socket interface with the Ethernet communications. So our control Logix 5580 ports support that, as well as the EN2T Ethernet modules in the control Logix support sockets. But you do need to use version 24 or newer firmware. And also on the compact logic side, the 5380 or the high performance compact logic controllers support it, as well as the 5370s. So either of those compact Logix controllers do support sockets. Therefore, we can use the MQTT add-on instructions with both of those controllers. Those of you that are familiar with MQTT, just keep in mind that the communications coming out of the controller will be using socket topics, and those topics can be subscribed or unsubscribed and published for that communication. So moving on to the Micro 800, the Micro 800, those controllers with the built-in Ethernet port, so that would be the 820s, the 850s, and the 870s, also support MQTT. And so there's a second sample code you can download that can be imported directly into Connected Components Workbench that will allow you this communication. And so the Connected Components Workbench programmed a little differently than the Logix. So we have user-defined function blocks that are available in the Micro 800. And those, function blocks support some of the MQTT functionality, like authentication, quality of service, and then the last will and testament, which is directly related to MQTT. And so this, so moving on, this gives you kind of a comprehensive diagram or architecture of what the IIoT architecture would look like. And so you've got your, in this case, the Micro 800 controllers connected, whether that's wired, Wi-Fi, cellular, up to the MQTT broker. So that could be a cloud service like Azure or Amazon Web Services. That could be an on-premise database like a SQL database. It doesn't have to be a cloud. But then you publish and subscribe that information. And that's how that works. Now, one other thing I forgot to mention about the Logix. Those of you that have used the sockets interface before may be aware of this, but Rockwell does not recommend sockets, the socket interface, for real-time control. We have other methods for that. We use RS links and FactoryTalk links, et cetera, for our real-time control and remote IO data. But the sockets interface is really designed to present data up to maybe an enterprise. So we don't really use it for real-time control, but it is a good method to produce some data that we may use for analysis or we want to store historically. Okay, so back to the architecture here. And again, the front end, we have our controllers connecting to the broker. And then on the back end, we have our enterprise analytics. And so Rockwell has the innovation suite, and that can connect directly to this information. We also have viewpoint web clients or custom analytics, et cetera. And that's essentially how this architecture looks. So if you think about this diagram versus the 6th layer of the Purdue model, we really have, what we have here is layer 1, or the controller layer, through the broker talking directly to the layer 5, or the enterprise layer. So again, you can see how this potentially could be a much more efficient way to get data up to the enterprise quickly. And a couple other things. One thing that's interesting about this architecture that may present itself in other ways, or present other use cases, is using this MQTT broker. You can create data exchanges between, and specifically on the Micro 800, between 8 Micro 800 controllers that you really couldn't do in a normal way. So you could have this broker could be, if it is a cloud, you could have large distances between these controllers, but they can still be sharing information. So that may create other use cases for controller to controller communication that we really didn't have before. So that's something interesting about this. So some of the applications, some of the use cases, could be remote monitoring, or inventory management, or those kinds of things. And so,
David, can I jump
yeah,
in real quick?
Sure.
I just want to make everyone aware, there is a YouTube video specifically that Rockwell's put out on the Micro 800 and IIoT. In fact, if you search Micro 800 Rockwell and IIoT, you'll see the video. So if you want to take a more in-depth look on how to set the configurations, it can be addressed there.
Yeah, thanks, Mike. And to kind of follow up with that, when you download the sample code, whether it's for the Logix or the Micro 800, there is a set of documentation associated with that code that will help you walk through what the code does, and how to import add-on instructions, etc. Like for example, the Logix MQTT add-on instruction really comes in 2 parts. There's one part that's a program that really acts as the communication backbone, and so that's the socket interface. And then the AOIs the AOIs, or the add-on instructions, handle the topic commands, etc. And so back to finish our discussion about our MQTT interface, we really can't complete the solution without our Compass partners. And so this is a list of partners that have, whether it's gateways or protocol converters or some hardware solutions to cloud storage or cloud network connectivity. All of these partners have great solutions that help us get all the way there. So just keep that in mind if you're looking at a IIoT solution, to keep these other vendors in mind as well. And so the last few minutes of our discussion, I want to introduce a new technology that Rockwell introduced back at the end of 2020 that you may not have heard of. And it's called the FactoryTalk Edge Gateway. And so the Edge Gateway is another option for us if we want to implement more of an industrial Internet of Things type of topology to our existing systems. And so I'm going to talk a little bit about it. So those of you that kind of played the inside game, that are aware of Rockwell, of some of Rockwell's solutions before they're actually released, you may know this technology as the FactoryTalk Links Information Gateway. That was the name that we were told earlier in the year. Then Rockwell decided to change it. And so the original name kind of describes a little bit more of what it does. And really what it does is it links the controllers directly to information systems. And so much the same way that the MQTT interface does, but the Edge Gateway takes it to another level. And so we'll spend a few more minutes talking about it. What's important about the Edge Gateway is to realize that we are truly linking in the Purdue model, the level 2 with the level 5 systems directly. And so the way we do that is really through there's a couple of pieces to the Edge Gateway. The first piece is the smart object that exists inside the controller. And then the second piece is the direct interface to some of the enterprise software systems that we'll talk about. So, and in between, and so what that does is, so when we link those two layers together, we are creating context down at the controller level for that data. And so what that does a couple of good things, but one of the main things that does is that creates a common data platform or a common data model throughout your system. And so in today's world, without something like an Edge Gateway or without using IIoT, typically your analysts at the top at the enterprise are having to recreate these data models because essentially what they get is just a bunch of data from the controls. And so what this does is in much the same way that Plant PAX helps that visualization and control layer, this gateway helps standardize your data between the control and the enterprise layer. And so let's talk a little bit about what kind of data we can put into this and we can push through this gateway. So quite a bit. So through Ethernet IP is a main source of data, but not only older controllers, version 16 and higher, but we can also connect to drives. And of course, the smart object that comes with it. So the smart object does require a newer controller. So you need version 28 plus, but through FactoryTalk links, through RS Links Enterprise, we can talk to a lot of our existing infrastructure. So even PLC 5s and SLICs and MicroLogix, we can do that. We can connect OPC UA, maybe at the level 2 layer of our information system. And of course, we could also use Kepware for the third-party data. So that's what in the IT world they call the ingress drivers, or where the data is coming from. And so using the smart object, we contextualize, or what we do essentially is we take that controller data and we turn it into information. And so that's a key part of what this does. And so we like to use fancy words like contextualize, but what we're really doing is we're turning that data into information. And we're doing it at the controller level now instead of all the way up at the enterprise. So there's a lot of benefits there. So at the enterprise, so where is this data going to be presented to our analysts? So we have a direct connection to the Azure IoT Hub. And so that would be more of a cloud type of architecture. Or we could just use SQL. We could connect this to MS SQL, and that could be like an on-premise type of solution if your organization isn't into cloud. And then as a future release, we're going to add functionality. This is the first release last fall. So as you'll see new releases come out, we'll add functionality to PTC ThingWorks, which is a So for those of you that don't know, PTC is one of the leaders in analytics, enterprise analytics software, and Rockwell has a very tight relationship with them. And we're doing a lot of integration between the PTC software and Rockwell software. And so this is part of that. So ThingWorx is going to be integrated in the future to this gateway. And finally, just to kind of wrap this. So where do I install this gateway? Where can I run the information for the edge gateway? Well, the good news is it's relatively light in software. So you can run this on a Windows 10 computer. You can even run this on a scalable compute module that sits in an in-chassis control Logix. And I think maybe that's why they changed the name to the Edge Gateway. That this can truly exist on the edge. Or you could use the industrial computer, with Windows, or all the way up to a server class system. Presumably, if you were creating an on-premise data system, it would certainly run on server class systems. So really want to appreciate everybody's time this morning. And I haven't had time to look at the chat to see if there's anything in the chat. I don't know, Mike, if you saw anything there.
There was one question, basically, what are the limitations on, specifically, I know what are the limitations to the add-on instructions? I'm going to try to pull some published documentation on it, but there are limitations, especially on the Micro 800 on the add-on instructions used there. So I will get that, and we will put that information with the presentation, but we will get that answered for you.
Yeah, and just to be clear, the add-on instruction does require the use of sockets on the control Logix and the compact Logix, so that would be part of that limitation too.
Correct.
Is following the sockets interface. So, okay, great. Well, thanks, Mike, and thanks everyone for tuning in. And have a great rest of your day. Appreciate your time.
All right. Thanks, guys. I hope to see you at Users Group next week. Thanks.